Jupiter isn't what you think it is. Most people are wrong about Jupiter because most of what you learn in school about it is wrong. It's not a giant gas sphere. Jupiter is a liquid planet. And as if that weren't strange enough, it's actually a liquid metal planet. Beneath those characteristic clouds lies one of the deepest mysteries of our solar system. Humans first observed Jupiter up close in 1974, when NASA's Pioneer 11 spacecraft flew past and sent back the first close-up images. In 1979, Voyager 1 continued this trend, capturing a series of images that allowed scientists to create the first moving footage of this giant planet. These observations were impressive, but they didn't fully explain Jupiter's true nature. Instead, they raised more questions for scientists, such as what the planet is made of and why it is so enormous. Today, we're going to delve deep into the most misunderstood planet in our solar system. What I'm about to reveal will completely change the way you see Jupiter, because the reality of this world is far stranger and more terrifying than anything you've learned in school. You think Jupiter is a gentle gas giant protecting Earth from asteroids? Wait until you discover its ocean of liquid metallic hydrogen, electrically conductive like copper wire. You believe it's nothing but swirling clouds and storms? I'll show you the planetary graveyard hidden deep within its core, where rocky worlds 10 times the size of Earth have been dissolved into cosmic soup. You think it's our guardian angel? The latest evidence suggests Jupiter may actually be a cosmic sniper, launching asteroids straight at us with deadly precision. The actual size of Jupiter is difficult to visualize. Not only is it enormous, but it also weighs more than the combined weight of all the other planets in our solar system. It occupies enough space to contain 1,000 Earths inside. To put it into perspective, if Earth were the size of a grape, Jupiter would be the size of a basketball. According to the general theory of solar system formation, it began with a large disk of rock, metal, gas, dust, and other materials orbiting the newly formed Sun. Over millions of years, all the matter in that disk continuously collided, forming larger masses. As these masses grew larger, gravity began to exert its influence, attracting even more matter. According to that theory, Jupiter formed when one of these masses grew so large that its gravitational pull began to draw in a large amount of gas. And this continued for billions of years, until it took the form we see today. That sounds plausible. And if true, it would mean Jupiter must have a massive, extremely dense, solid, rocky, and metallic core inside. Another hypothesis, just for fun, is that Jupiter actually began its life as a separate giant cloud of gas just outside the early solar system. Over time, that cloud grew so large that it eventually collapsed under its own gravity and formed a dense ball of gas. This is very similar to how a star is formed. The only difference is that stars need a much larger cloud of gas to start. So in this case, you just have one very large planet, and then eventually that new planet is pulled in by the sun's gravity and stabilizes in orbit. If this were true, Jupiter wouldn't actually have a core at all. It would just be like a giant, multi-layered cake made entirely of gas. But the theory most of us are taught is about a large, solid core that holds all the gas. And again, that sounds plausible. It's not crazy to believe, but it's not accurate either. Our first real breakthrough in understanding Jupiter came in the mid-1990s. And this is one of those incredible coincidences, too good to be true. But in July 1995, the planet was struck by a comet. This isn't a common occurrence. It's estimated that a collision like this might happen once every 6,000 years. But we were there to witness it, and we had the technology to observe the whole process. This comet, named Shoemaker-Levy 9, is a massive mass of ice and rock hurtling through the solar system at a speed of 216,000 kilometers per hour. It's difficult to say its exact size, because by the time we found it, Jupiter's powerful gravitational pull had broken it into dozens of pieces. But the largest piece still has a diameter of about 2 kilometers. At the time, NASA had its newly operational Hubble telescope ready to observe the collision. But there was a major problem. The comet's debris would hit the far side of Jupiter, beyond Earth's view. We would miss it. Except that, coincidentally, NASA also had a spacecraft heading to Jupiter at the same time this rare event was happening. This is the Galileo probe, named after the first astronomer to study the planet with a telescope. Launched in 1989, its mission was to study Jupiter and its moons. It was scheduled to arrive in December 1995, by which time it had a clear view of the comet collisions. What it witnessed were 21 separate collisions within 6 days. The largest comet fragment released energy equivalent to 300 million atomic bombs, creating the largest explosion ever recorded on camera. As the planet rotated, the Hubble telescope was able to observe the aftermath of those collisions. They actually left giant black holes in the clouds and created enormous columns of debris thousands of kilometers high. This is where the Galileo spacecraft approached. Parts of Jupiter's interior had been ejected into space, and the probe was able to fly through them. This is the first time we've seen what lies beneath the clouds that humans have gazed upon with wonder for hundreds of years. The most interesting thing Galileo discovered was actually water. Lots of water. And scientists found that quite strange. So strange that they embarked on another mission to Jupiter with a new probe, specifically designed to search for the planet's true nature. That mission was named Juno. The spacecraft was launched in 2011 and arrived in 2016 to begin unraveling the mystery within Jupiter's core. So when we say that everything you were taught in school was wrong, It's because we didn't even begin to learn the truth until the last decade. So here are some things your science teacher didn't know back then. Jupiter isn't made of gas. It's covered in thick clouds of gas that make up all those swirls and storms. But those clouds are just a thin layer on top of something much stranger underneath. But let's start from the top. In Jupiter's clouds, temperatures are below minus 100 degrees Celsius. Ice crystals interact with ammonia, which acts as a natural antifreeze, allowing liquid water to remain in the upper cloud layer. When water droplets collide with the ice crystals, the clouds become electrically charged, causing massive thunderstorms to rage across the surface. This mixture of supercooled water and ammonia eventually coalesces into thick hailstones. They fall to the lower atmosphere, where they melt into rain, evaporate, and rise again to begin the whole process. Hot air currents rise to fuel these violent surface storms that extend deep into the planet's atmosphere. This is what we see in the Great Red Spot. Not only is it thousands of kilometers in diameter, but it also stretches hundreds of kilometers into the ammonia rain. The red spot rises higher than any other cloud on Jupiter. It absorbs much of the sun's ultraviolet radiation, then reacting with chemical compounds to create that deep red color. Imagine a cloud 10 times taller than Mount Everest and 10 times deeper than the ocean. And even that wouldn't be enough to grasp the scale of the red spot. However spectacular this outermost layer may look, the average depth of these ammonia and water clouds is only about 50 kilometers. As we descend beneath the clouds and into Jupiter's lower atmosphere, the temperature begins to rise. This temperature is caused by pressure. When you compress molecules, you concentrate their energy. And pressure is created by gravity. The planet's immense mass is pulling all this matter down and compressing it even more until some truly bizarre phenomena begin to occur. The deeper you go into Jupiter's gravitational zone, the higher the temperature and pressure become. It's like walking through an increasingly dense fog until it eventually turns into liquid. The only difference is that here, the fog isn't water, but hydrogen. Hydrogen is the lightest element in the universe, and in an extremely gravitational environment like the inside of Jupiter, it's the only thing that can float. All the heavier elements have been pulled down to the planet's core. At a depth of about 1,000 kilometers below the cloud layer, hydrogen gas completes its transition to a liquid state. And this is the closest we can see to Jupiter's surface, an ocean of liquid hydrogen, the largest ocean in the solar system. So, although this giant planet may be covered by a thin layer of gas, it is certainly not composed of gas. It is a liquid planet. But this is a stranger liquid than anything we've ever seen before. On Earth, we can liquefy hydrogen by cooling it down. Earth's atmospheric pressure lowers the boiling point of hydrogen to around minus 250 degrees Celsius. But on Jupiter, the opposite effect is happening. The extreme pressure raises the boiling point so high that it can exist in liquid form, even at temperatures above 1,000 degrees Celsius. This ocean is about 20,000 kilometers deep, 2,000 times deeper than Earth's oceans. And when we reach the bottom, the pressure and temperature created by the gravity hole have a very strange effect. Under pressure millions of times greater than the Earth's surface at 10,000 degrees Celsius, hydrogen transforms into metallic hydrogen. That doesn't mean it solidifies like steel. It's still a liquid, but a metallic liquid, perhaps similar to the mercury inside a thermometer. The biggest change here is that metallic hydrogen is now capable of conducting electricity. Jupiter's gravity compresses this region so tightly that electrons detach from the hydrogen atoms and freely circulate. This liquid metallic hydrogen makes up the majority of the planet's interior. It lies at a depth of approximately 40,000 kilometers. And at the very bottom, deep inside everything, is Jupiter's solid core, roughly speaking. Previously, we believed that at the center of Jupiter was a dense, massive object, about the size of Earth, composed primarily of iron and rock. That sounds plausible, but new research is revealing that the planet's core is far more complex. The boundary between the liquid metal and the solid core isn't a clear line. The two layers are mixed together. The fuzzy core spans about half the planet's radius. Scientists now believe it's like a thick, viscous mixture of rock and liquid metal blended together without any clear boundaries. It's currently uncertain whether this is a unique characteristic of Jupiter or if all gas giants are like this. It is thought that if Jupiter's core has an unusual composition, it is most likely due to some massive collision that occurred in the early days of the solar system. There may have once been a rocky planet 10 times the size of Earth that collided with Jupiter. The energy from that collision dispersed and diluted the planet's solid core. This could also help explain why Jupiter was able to grow so large. But this is where the story of Jupiter becomes truly thought-provoking. Recent computer simulations suggest that the planet's fuzzy core may be a result of an ongoing process. Asteroids and comets that come too close to Jupiter don't just burn up. They are pulled deep inside, where the pressure and temperature dissolve them at the molecular level. Therefore, many scientists liken Jupiter to a cosmic stomach. Over billions of years, the planet may have swallowed countless pieces of space debris, all of which have blended into its core. But the story doesn't end there. For decades, we thought of Jupiter as a shield protecting Earth. But recent studies reveal a more complex picture. Jupiter's immense gravitational pull can sometimes deflect objects and hurl them into the inner solar system. Many near-Earth asteroids today bear the marks of close approaches to this giant planet. Jupiter also possesses the strongest magnetic field of any planet, about 20,000 times stronger than Earth's. It creates extremely dangerous radiation belts and emits radio waves so powerful they can be detected from very far away. Even Jupiter's atmosphere is changing. The Great Red Spot is shrinking and may disappear within the next few decades. Interestingly, Jupiter radiates more heat than it receives from the Sun, making it almost like an unformed star. If it had about 13 times the mass, our solar system might have had 2 suns instead of 1. We know that Jupiter has a strange, massive core. but we don't know how it formed. It's a giant mystery in the sky, waiting to be solved. And eventually, we will find the answer. Until we truly understand it, Jupiter remains one of the greatest mysteries of the solar system. It's a world that's difficult to categorize, somewhere between planet and star, between protector and destroyer. Inside Jupiter lies a vast ocean of liquid metallic hydrogen, an extremely rare state of matter nearly impossible for humans to replicate. The planet itself becomes a natural laboratory for studying matter under extreme conditions. If you found the story about Jupiter interesting, please like the video and subscribe to the channel. Don't miss other amazing cosmic discoveries in future videos. See you soon!